I'm so sorry, guys. I'm very late because something. So we were discussing in the last class how to deal with the motion of center of mass, right? सब लोग आ गए, सब लोग जग गए, सब लोग हैं मेरे साथ. Everybody is here. Hello, can you please type yes? Okay, great. So we were discussing about the motion of center of mass, and I told you that the process of finding out the center of mass through integration and what we did, that process is sort of removed from the rest of the chapter. So the maximum thing that you can if the question is not specifically about finding center of mass, the maximum thing that we can you can be dealing with is those four objects, that half ring, half disk, hollow hemisphere, solid hemisphere, and that's why I said कि उन चारों के आपको center of mass की values को याद रखना है. Okay, ring के लिए 2r by pi, half disk के लिए 4r by 3 pi, hollow hemisphere के लिए r by 2, और solid के लिए I think it was 3r by 8, right? So you have to just remember these values. But like I said, the process that you saw there, the process of integration to find physical quantities about an object, this process will now become a permanent feature. So if you are yet to become comfortable with that integration wala process, I told you in the last class also, and I will tell you again, that do the derivation of all the center of masses that we have done again. Aram se think about the steps in your own mind and then do them again if you are still uncomfortable. Okay. Then we talked about the motion of center of mass, and we defined a quantity called the velocity of center of mass. We defined a quantity called the acceleration of center of mass, and we defined something called the external force on the system. यश क्या हो गया भाई तेरे को? इधर सुनना जो मैं बोल रहा हूं. So we also defined the second law, counterpart for the system of point particles, and that is that external force is equal to mass into acceleration of center of mass. Right, so VCOM was defined as, just like XCOM, it was M1 V1 plus M2 V2 and so on, divided by M1 plus M2 plus. So acceleration of center of mass is M1 A1 plus M2 A2 plus this divided by M1 plus M2. And this we defined as the summation of F internal plus the summation of F external. This becomes 0, right? And this does not become 0. So may or may not be 0. Right? Now the reason I am saying that the integration wala part is not going to sort of make a big contribution here. The reason is that ये जो M1 V1 plus M2 V2 लिखा है, इसको हम कभी इंटीग्रल VDM नहीं लिखेंगे, उसका कोई मतलब नहीं. That is not possible because I will tell you the reason why. In a moment, I'll tell you the reason why. So, what I want to do before I tell you the reason why we are not going to ever use calculus here is to ask you a series of questions where you will give me a single word answer. Okay, everybody, please be ready. Single word answer. If f external on a system is equal to 0, then ACOM will be equal to how much? Single answer. If f external is equal to 0, then acceleration of center of mass is going to be how much? Very good. Yes. 0. Okay. Now comes a very weird question. If acceleration of mass is equal to 0, right, then is it necessary that A1, A2, A3 are individually 0, right? Please listen to the question very carefully. If acceleration of center of mass is 0, then is it necessary that A1, A2, A3 should individually be 0? Acceleration can be negative. Yes, they are vectors. Yes. Very good. So I'm very happy that you have this very nice, all of you who have answered this very nice understanding. So the answer will be no. That means that even though acceleration of center of mass is 0, even though this guy is equal to 0, this and this and this, not necessarily 0. मैंने वो स्पेलिंग गलत लिख दिया मेरे ख्याल से. Okay. Now this has consequences. आप अभी अभी तो मैंने मैथमेटिकली आपको बता दिया, मैथमेटिकली आपने भी समझ लिया, लेकिन इसका कॉन्सिक्वेंस ये है. Okay, this is the third question coming up now. I'll just change the slide for a minute. इसका कॉन्सिक्वेंस ये है कि supposing that we have a car and we choose this system as the car, and we say that f external is equal to 0, therefore acceleration of center of mass is equal to 0. अब इस कार के अंदर एक बच्चा है या कोई और, मतलब कोई adult, I don't know, some human is there, and what this guy is doing is what I hope all of you have done. स्टेयरिंग व्हील पकड़ के आगे पीछे हो रहा है. ओके, ये स्टेयरिंग व्हील पकड़ के आगे पीछे हो रहा है. So acceleration of the center of mass will be given by mass of the person into acceleration of the person plus mass of the car into acceleration of the car. but this is equal to 0. So what will happen when the person accelerates? If a person is not equal to 0, then what can you tell me about a car? What can you tell me about the acceleration of the car? Okay? क्वेश्चन मैं फिर से बोल रहा हूँ. हमने एक ऐसा सिस्टम चूज किया. हाँ विश्वजीत, गुड. हमने एक ऐसा सिस्टम चूज किया जिसमें दो पार्टिकल्स. हाँ सत्यम, बिल्कुल सही. दो पार्टिकल्स क्या हैं? हाँ राधिका, दो पार्टिकल्स क्या हैं? एक पर्सन है और कार है. And I am telling you that the external force on this system is 0. Okay? So the acceleration of center of mass should be 0. But acceleration of center of mass of this system of two particles will be given by mass of person into acceleration of person divided plus mass of car into acceleration of car divided by m1 plus m2. This will be the acceleration of center of mass. So if the person inside decides to accelerate, what will happen to the acceleration of the car? Will it be equal to 0 or will it be non-zero? That is the question. Ha, ha. Very good. Yes, yes. So, नहीं अथर्व, अगर वो एक्सेलरेशन ऑफ कार 0 हो गया तो एक्सेलरेशन ऑफ सेंटर ऑफ मास भी 0 नहीं हो सकता है ना. अगर एक्सेलरेशन ऑफ कार 0 हो गया, 3 plus 0 is equal to, अथर्व कितना होएगा ये? This will be equal to how much? 3. But if you want this to be 0, then this should be how much? Ha. Exactly. So basically, this quantity plus this quantity should be 0. And I am asking, if this quantity is non-zero, then this quantity will be 0 or non-zero? So this will be not equal to 0. I hope ये सबने कार में experience किया है. You know, as a child, I remember sitting in the car, moving forward. When I move forward, ताकत थोड़ी लगानी पड़ती है, but when I move forward, the car sort of slightly, very very slightly moves backwards. And if I move backward, the car moves forward. Basically, स्टेयरिंग पकड़ के अगर हम ऑसिलेट होने लग जाएं तो कार भी जो है थोड़ा सा आगे पीछे होने लगती है. Another practical application of this. No, it's not equal and opposite forces. No. It is equal and opposite forces. Yes. I mean that is why F external is equal to MSCM, right? So another aspect, another practical application of this is a rocket in space, right? So supposing we have a rocket in space. Now what this rocket is going to do is that it is going to eject gas, right? So if I have this as the system where we have acceleration of center of mass is equal to 0 because there is no external force on the rocket. Okay? The rocket is in space, and if it is in space, then there is no gravity. It is far away from every planet and every star. So acceleration of center of mass is 0, right? What this means is the acceleration of rocket into mass of rocket plus mass of the ejected gas into acceleration of the ejected gas divided by mass of the rocket plus mass of the gas must be equal to 0, right? So acceleration of rocket and acceleration of gas are connected to each other with this relation. So all you have to do is accelerate the gas in the backward direction, and therefore the rocket will have an acceleration in the forward direction, right? What can you say about the center of mass of the system? Can you think? Can you tell me what will happen to the center of mass of this system? So I'll give you a scenario. The scenario is that we take a rocket in space, okay, far away from all the planets and all the stars, no gravity is there. And I ensure that with respect to some observer, the rocket is stationary. Okay, the rocket is not moving. Now, after the rocket is ensured to be stationary, the rocket is fired, right? That means the gases they accelerate backwards and the rocket accelerates in the forward direction. Okay, and this keeps on happening. I mean, the rocket keeps on firing for a very long time, and with respect to the observer, now the rocket has traveled, I don't know, millions of miles. Where is the center of mass? Where is the center of mass of the system? Where is the center of mass of the system? मतलब ये थोड़ा मैं एडवांस क्वेश्चन पूछ रहा हूँ, तो इफ यू आर नॉट एबल टू आंसर डोंट वरी, जस्ट थिंक एंड टेल मी. Right? I hope you have understood the question. I go into space, far away from every planet, every star, and I stand somewhere and I take a rocket and I make sure that this rocket is stationary in front of me. And then maybe I have a remote control in my hand. I fire the rocket flies off, and it flies off for millions of miles. Where is the center of mass of the rocket? Okay, chalo, ठीक है, छोड़ो. We'll answer this question in a moment, right? So two questions I have to answer. Number one, why don't we use integration here? And number two, where is the center of mass of the rocket? अभी आते हैं रोहन, अभी आते हैं. We'll come back to it. Okay, coming back to this again, one word answers. So if f external is 0, then ACOM is equal to 0, right? Then is it necessary that A1, A2 are individually 0? No, it is not. Okay. Next question is, then dVcom by dt is equal to how much? Okay, so forget about the red brackets for the moment. वो एक extra question था. We are continuing from ACOM is equal to 0. So if f external is equal to 0, then ACOM is equal to 0. This is what you answered. And now I'm asking, then the value of dVcom by dt will be what? Very good. Yes, Rohan. और कोई? हाँ, विश्वजीत. Yes, yes, yes. भाई ACOM और VCOM में क्या रिलेशनशिप होता है? ACOM और VCOM में क्या रिलेशनशिप होता है? ACOM is equal to dVcom by dt. Right? Now, if ACOM is 0, then dVcom by dt must be 0. Therefore, VCOM must be what? Very good. Yes, 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 yes. Yes, 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 absolutely. Anything differentiated with respect to time, Okay, anything differentiated with respect to time is zero. That means that that thing must be constant. Okay, that thing must be constant. I'm changing the slide. I want to go to the next slide. I'm continuing this statement only. So हमने अभी तक क्या लिखा है? If f external is equal to 0, this implies that ACUM is equal to 0. This implies that dVCUM by dt is equal to 0. This implies that VCUM is equal to constant, right? I hope everybody is agreeing with this. VCUM is equal to M1 V1 plus M2 V2 plus M3 V3 divided by M1 plus M2 plus M3, right? ये VCUM है, and this is constant. Okay, and again I would like to ask you, does this mean that V1, V2, V3 are all constants? Please answer the question. If VCUM is equal to M1 V1 plus M2 V2 plus M3 V3 and so on, and this is equal to a constant, then does this mean that V1 plus V2 plus V1 comma V2 comma should also be constants? Basically, what I'm asking you is that if x plus y plus z is equal to 3, then x, y, z is also constant. Is it true that x, y, z is constant? है ना अभिन? क्या values होंगी x, y, z की? सोनल बताइए. What will be the values of x, y, z? 1, 1, 1, 1. Very nice. Very good. What about 1.5 plus 0.5 plus 1? ये possible है क्या? Is this possible? Or maybe 3 minus 1 plus minus 1. ये possible है? अजीब. तो फिर आप बताइए, फिर से मैं क्वेश्चन पूछ रहा हूँ. अगर x, y, z, x plus y plus z is equal to 3 है, तो x और y और z ये कांस्टेंट्स हैं या वेरिएबल्स? वेरिएबल है ना? So again, I will ask the question. If M1 V1 plus M2 V2 plus M3 V3 and so on is constant, then does this mean that V1 and V2 and V3 and V4 and so on, they are individually constant necessarily? No. Okay. And if I am telling you that the mass of this system is constant, then obviously the denominator is constant, right? So this means that if F external on a system is 0, then M1 V1 plus M2 V2 plus M3 V3 and so on, the sum of these things is constant. ये कहीं देखा है पहले? Have you seen this? Or are you able to recognize what I have written in the in the green rectangle. नहीं भाई राधिका, सोचो, देखो. हाँ अभिजीत, yes. हाँ. Right. So the law of conservation of momentum is not really something which is, sort of I can just get up and say कि नहीं नहीं देखो ये तो conserved होता है. It is a direct consequence of Newton's third law, and it is a direct consequence of not I'll not say third law, I'll say Newton's laws. It is a direct consequence of Newton's laws and our definition of velocity and acceleration. It is a naturally occurring law, right? I mean, अभी तक जो भी हमने discuss किया, right? I hope all of you are concurring with it, agreeing with it, that if F external is zero, then ACM is zero, then dVCM by dt is zero, then VCM is constant. This is a logical chain of mathematical steps. And if VCM is constant, then this quantity must be constant. So we define something called linear momentum as P is equal to mv. It is a vector quantity and its units are kilogram meter per second, right? And if then P1 plus P2 plus P3 must be equal to constant. Please notice, ये जो रेड में मैंने लिखा है ना, इसका इसका लिखने का एक पर्पस है. पर्पस ये है, the purpose of writing this is that you can have a system in which the individual particles, they are moving around. They have their own individual velocities. M1 has velocity V1, M2 has velocity V2, M3 has velocity V3. They are all moving around and they can all change their velocities, no problem. But the quantity called M1 V1 plus M2 V2 plus M3 V3, this quantity cannot change. V1, V2, V3 can individually change. तो दो पार्टिकल एक सिस्टम के अंदर आपस में भिड़ गए तो उनकी इंडिविजुअल वेलोसिटीज चेंज हो गई, लेकिन उनकी वेलोसिटीज ऐसे चेंज होंगी such that the momentum of the system it remains constant. Okay, it remains constant. ये आया सबको समझ में? This is understood. Anybody not understanding, please tell me now. Anybody not understanding, please tell me now. ठीक है? Okay. So this then forms the second last tool in our in our sort of armory of physics, okay, especially mechanics. So what are the tools that we have? Well, we have the definition of velocity, the definition of acceleration, Newton's second law for a point particle. Then we have the constraint equation, the string constraint and the wedge constraints. Then we have the concept of pseudo force. Then for a collection of point particles. Okay, so this law of conservation of momentum does not have any consequence on a single particle. कोई मतलब नहीं है, वहां नहीं apply कर सकते. Then for a collection of point particles, we have the definition of the position of center of mass, the definition of the velocity and acceleration of center of mass, Newton's second law or Newton's law for collection of particles, and this law of conservation of momentum. Okay, and we are going to see that we have another basic law we are going to learn in the next chapter, that is the law of conservation of angular momentum. So these laws are independent of the chapter. That means that in the future, I'm going to give you a question where there will be two charges and they will be attracted or repelled by each other. I don't know. And I will ask you something about the two charges, right? So you will know what the electrostatic force is. You will know what the work done by electrostatic force is, right? But when you have two charges which are attracting each other or repelling each other, their velocities are continuously changing. And if I ask you for the velocity of the system or velocity of the one particle, then when you apply work energy theorem, you're going to end up with one equation and two unknowns, because velocity of particle 1 will be v1, velocity of particle 2 will be v2. But at that time, in your mind, it should strike कि अरे ये दो पार्टिकल को अगर मैं एक सिस्टम ले लूं तो ये सिस्टम के बाहर तो कुछ है ही नहीं, तो इसका मतलब एक्सटर्नल फोर्स ऑन द सिस्टम तो जीरो है. अगर एक्सटर्नल फोर्स जीरो है, इसका मतलब कि ये सिस्टम का मोमेंटम कंजर्व्ड होना चाहिए. इसका मतलब m1 v1 plus m2 v2 must be equal to 0, and that gives you the second relation between v1 and v2, and then you can finally solve the question, right? Similarly, I can give you questions in the chapter of magnetism, where this will happen. I can give you the questions in the chapter of gravitation, where this will happen, right? तो ग्रेविटेशन में समथिंग लाइक कोई कॉमेट जा रहा है, वो दो पार्ट्स में तीन टुकड़ों में टूट गया, अब क्या होगा? कोई दिक्कत नहीं है. अगर वो एक्सटर्नल फोर्स उस पे जीरो है, कॉमेट स्पेस में है, वी आर अज्यूमिंग दैट एक्सटर्नल फोर्स इज जीरो, देन द मोमेंटम ऑफ द थ्री पार्टिकल्स मस्ट रिमेन the sum of momentum of the three particles must remain constant, right? So these laws are basically independent of the chapter, and they are tools with you for analyzing any type of question. Okay. Before I teach you the application of law of conservation of momentum, there is something else that I must talk about first, and then we can go on to a discussion of law of conservation of momentum, right? So I will change the slide now. So we have discussed up till now that if F external is equal to 0, ACOM is equal to 0, and this means that dVCOM by dt is equal to 0. This means that VCOM is equal to constant, right? यहाँ तक हमने अभी तक डिस्कस किया. ये VCOM is constant is nothing but the law of conservation of momentum. If further we know that VCOM is 0, then drCOM by dt, that is the rate of change of position of the center of mass, that is the rate of change of position of the center of mass, will be how much? Will be how much? Very good, Sonal. Yes, yes, Rohan. Very good. नहीं अभिजीत गलत आंसर है. So what is the relationship between VCOM and RCOM? VCOM is equal to dr by dt. Okay? गलत आंसर है जोहेब. क्या एक बार देखो तो. X is equal to y, x equal to 0, y equal to, जोहेब बताइए कितना आएगा? कांस्टेंट 0 आएगा ना आंसर. So if VCOM is equal to 0 and we know that VCOM is equal to dr by dt, then this must also be 0. What you are doing is you are skipping to the next part of the question where I will ask RCOM must be what? If dr by dt is 0, then r must be what? The rate of change of position of center of mass is 0. This means that the position of center of mass must be constant. Okay, position of center of mass must be constant. Now remember that position of center of mass is nothing but the x coordinate of center of mass I cap plus y coordinate of center of mass j cap, right? And x coordinate of center of mass is equal to m1 x1 plus m2 x2 and so on divided by m1 plus m2. Y coordinate of center of mass is equal to m1 y1 plus m2 y2 and so on divided by m1 plus m2. ठीक है? Okay. So my next question is that if XUM is equal to constant, then is it necessary that लिखना ही बंद कर दिया क्यों? अच्छा, that x1, x2 are also constant? Is it necessary? Let me put it in the brackets. Is it necessary? It is just a extrapolation of the question that you have been answering up till now. So the answer is no. The answer is no. So now थोड़ा सा premature है, I think, but still I want to ask this question again. I want to go back to the rocket. तो मैं एक रॉकेट को स्पेस में लेके गया, बिल्कुल दूर, जहां पे कोई फोर्स नहीं लगी है रॉकेट पे, और मैंने रॉकेट को फायर कर दिया. रॉकेट को स्टेशनरी रखा है पहले, ये मैंने अश्योर किया है रॉकेट स्टेशनरी है, और मैंने फिर रॉकेट को फायर कर दिया. The gases, they move backward, therefore the rocket body moves forward, and after a time I see that the rocket has traveled a distance of 1,000,000 miles. Where is the center of mass of the system? Where is the center of mass of the system? Where is the center of mass of the system? where is the center of mass of the system? नहीं, अभी भी नहीं. Okay. अभी वापस आते हैं. We'll come back to it. So this is okay. नहीं नहीं अभी. This is okay. This is understood that if f external is 0, then नहीं नहीं Zohair. If f external is 0 and VCM is equal to 0, then the x coordinate of center of mass must be 0 and constant, and y coordinate of center of mass must be constant. ठीक है, अभी अभी भूल जाओ रॉकेट के बारे में, वापस आते हैं. So let me write what I have just said again. So if f external is equal to 0 and velocity of center of mass is equal to 0, then x coordinate and y coordinate of center of mass will be constant. If only the x component of the center, if only the x component of external force is 0, right? Then this would mean that only acceleration of center of mass ka x component would be equal to 0. This would mean that d by dt of the x component of velocity of center of mass will be 0. This means that only the x component of the velocity of center of mass will be constant, not 0. And if further velocity of center of mass is equal to 0, then the x coordinate of center of mass will be 0, will be constant. So basically what I'm trying to say is that if you have understood this, right, then it also works individually for components. Because if you remember in projectile motion, I had told you that for some reason, we don't know what, for some mysterious reason, the motion of particles between x and y axis is independent of each other. So the motion of a particle along y axis is completely independent of the motion of the particle along x axis, right? It really, they really cannot affect each other. तो अगर x डायरेक्शन में एक्सटर्नल फोर्स 0 है, तो x डायरेक्शन का वेलोसिटी ऑफ सेंटर ऑफ मास कांस्टेंट हो जाएगा, x कंपोनेंट ऑफ मोमेंटम कंजर्व्ड रहेगा, और y कंपोनेंट ऑफ मोमेंटम चेंज होता रहेगा या कुछ भी होता रहेगा, उससे हमें मतलब ही नहीं, लेना देना ही नहीं. सिमिलरली y कंपोनेंट को हम सेपरेटली देख सकते हैं फ्रॉम द x कंपोनेंट. So xum is equal to constant implies that m1 x1 plus m2 x2 and so on, this must be constant, because remember नीचे m1 plus m2 plus m3 है जो कि constant because the mass of the system is constant. This is sometimes referred to as the law of conservation of center of mass. Okay. When does this law kick in? When does this law show itself? When is this law valid? It is valid under two very, very strict conditions. Condition number one is that the external force on the system along a particular axis at least must be 0, and further the velocity of center of mass along that axis along which the external force is 0 must also be 0, right? If that is the case, then the center of mass x coordinate or the center of mass coordinate along that axis will remain constant. x1, x2, x3, which are the x coordinates of individual particles, will and can and may move, may change with time. But the quantity m1 x1 plus m2 x2 plus m3 x3, that will not change with time. So I want to now show you a simple question. So we have a boat and we have a person who is standing on the boat. Mass of this person is 50 kilograms. Mass of the boat is 100 kilograms. And the length of the boat, 6 meters. Assume no friction between boat and water. What will be the distance traveled by man, by boat, sorry, if man walks, sorry, to the other end of boat. I hope everybody is understanding the question, and I hope that everybody has experienced this. I'm not talking about a big boat. I'm talking about a small raft sort of thing. If ever you have on a river or on the sea uh, climbed a small boat, then it is initially a very weird experience. It is a weird experience because it is something you have, your brain has never uh, your brain has never processed this kind of information before. When you are on the ground, then when you walk forward, the ground does not move. But on the boat, when you walk forward, the boat is going to move backwards. And this is very disorienting initially at first. Okay. So if you have never done this, in the future when you do, you will find this disorientation. Remember that it is simply because of the fact that the boat is moving backward, that this disorientation is happening. But why is the boat moving backward in the first place, and by what distance will it move backward as I walk from one end to the other end? So to do this, what I'm going to do is that I am going to draw an XY axis like this. So this is the X axis, this is the Y axis, right? Please don't attempt to do the problem. Let me show you how to do it, and then I will give you another which you will attempt. Remember that we are talking about the mechanics of a system of particles. Okay? So if you say, ki, nahi, I only want to talk about the man, or if you say, I only want to talk about the boat, then basically what you are doing is you are going back to what we have already studied, which is not going to be useful here because remember, we are upgrading our knowledge. We are trying to handle the position, the velocity, the acceleration, Newton's second law, and work energy theorem. and now the conservation of linear momentum on a system of particles. So the first thing that you have to do, okay, and I will keep on repeating this uh, so that it does not slip your mind. So the first thing that you have to do is to choose your system. The system must comprise of two or more objects. You cannot choose a system consisting of only one object, then nothing will work. Then you'll just go back to your to the mechanics that we have already studied. So here I choose a system, and by choosing a system, I simply mean that you are drawing a boundary, a mental boundary. Of course, you don't have to draw it on the paper itself. So I choose a boundary, and therefore I choose a system, which in this case is man plus boat. Okay, the system is man plus boat. Now, I look at the system and I see that the external force along the x-axis is zero. Okay, I look at the system and I see that the external force along the x-axis is zero. Sorry. So for the chosen system, हाँ y axis पे अभी हम बात नहीं कर रहे हैं. For the chosen system, summation of forces along the x-axis is equal to zero. Right. So F external along the x-axis is equal to zero. Also, since velocity of center of mass along the x-axis is equal to zero, this means that the x coordinate of center of mass must be constant. The x coordinate of center of mass must be constant, cannot be variable. Okay? Now, if x coordinate of center of mass is constant, that means that whatever happens, m1 x1 plus m2 x2 divided by m1 plus m2 must remain constant. So let's find the center of mass of the system right now. Only the x coordinate we are interested in. Okay, only the x coordinate we are interested in. So रुक जाओ, हाँ राधिका एक सेकंड में बस. तो आदमी जो है उसका सेंटर ऑफ मास यहाँ कहीं रहेगा, और ये जो बोट है इसका सेंटर ऑफ मास यहाँ पे रहेगा. राइट, बोट का सेंटर ऑफ मास यहाँ पे रहेगा, बीच में रहेगा. Because we know, right, for symmetrical and uniform objects, center of mass is at the geometrical center. Okay? So the x coordinate of center of mass must be equal to the mass of the man into x coordinate of the man plus mass of the boat into x coordinate of boat divided by mass of the man plus mass of the boat. So this will be equal to mass of the man 50, the x coordinate of the man is 0, plus mass of the boat is 100, and the x coordinate of the boat is 3 divided by 50 plus 100. Okay, this is the x coordinate of the center of mass of the system. Now, when the man walks from one end of the boat to the other end of the boat, when the man walks from one end of the boat to the other end of the boat, this obviously means that the location, the x coordinate of the man has changed and the x coordinate of the boat has changed. How has it changed? We don't know. That is what we are trying to find out. What is the final picture? I have no idea. Okay, so just for clarity's sake, just for the sake of visual clarity, what I will say is that look, the boat has moved here, and the man is now, of course, here because the man is at the other end of the boat. Okay, and I will also assume that the distance traveled by the boat, that means that this distance, okay, this distance is equal to, I don't know, let's say a l x, जो भी आप चूज करना चाहो, मैंने a चूज किया. So the blue picture, remember that my system is the same, right? Man plus boat. So the blue picture represents the final position of the man and the boat, and the black picture represents the uh, initial picture of the man and the boat. Now, two things to remember. Number one, I have no idea whether this is visually accurate or not. I have just drawn this so that I can draw the two pictures separately. Okay. Number two, my origin, the origin that I have chosen, the yellow origin that I have chosen, does not move with the boat and the man. Okay. That cannot be done. So my origin remains stationary, right? And I am assuming that as the man moves to the other end of the boat itself moves a distance of a uh, from the origin. So now let's calculate the new x coordinate of center of mass. But we know that this x coordinate of center of mass that we calculate is not really new. It is equal to the x coordinate of the center of mass, which was there previously, because of the fact that F external along the x-axis is 0, VCM along the x-axis is 0. Therefore, the x-coordinate of the center of mass cannot change. So again, the x-coordinate of center of mass will be given by the same formula. So let me apply. This will be equal to mass of the man into the x-coordinate of the man, right? So the x-coordinate of the man पहले तो 0 था, लेकिन अब ये हो गया x-coordinate of the center of mass of the man. And what is this distance? What is this distance? What is the distance of this red dot from the origin? What is this distance? ये कितना distance है? आपको केवल देखना है, डायग्राम देख के और आपको पता चल जाएगा. All you have to do is look at the diagram and you will know what is this distance. बताओ भाई, बाकी लोग बताओ. 12 नहीं, 12 नहीं हो सकता है ना. It it cannot be 12 because this is 6 meters and this is 6 meters. So this cannot be 12, right? I mean, ये बीच में ये लोचा है ना. And it cannot be x. You have to measure. तो यहाँ से यहाँ मैं आपको बता रहा हूँ a है और यहाँ से यहाँ 6 है. Now can you tell me x क्या है, Abhijit? I can't understand. What is x? हाँ, रजत आया. हाँ, गायब हो जाता है रजत. So this is a plus 6. Please look at the diagram. It is obvious. There is no technicality involved here. Wherever there is a technicality, I stop. There is no technicality here. The red dot on the blue man is at a distance of a plus 6 from the origin, plus mass of the boat into center of mass of the boat. So basically, I'm asking you for now. जोहेब, आपको केवल ये आपको नापना है, सिर्फ ऐसा मुश्किल चीज नहीं है. ये रेड डॉट से इस एक्सिस का डिस्टेंस ऐसे नापना है, ऐसे. Right, so let's say that we have a measuring tape with us. Then we open the measuring tape from here to here, and we get A, and then we further measure from here to here, and we get 3. So what is the distance of the red dot from the origin? It is equal to A plus 3 divided by 50 plus 100. Okay, so now the denominator cancels out, उसका तो कोई रोल ही नहीं है basically, and I get 300 is equal to 50A plus 300 plus 100A minus 300, right? So 300 and 300 cancels out, and I get 150A is equal to minus 300. Okay. Sorry, ये plus है ना ये. So this means that A is equal to minus 2 meters. So don't look at my diagram. I mean, look at my diagram for measuring things. But my diagram is completely inaccurate because A is minus 2 meters. That means that as the man walks to the other end of the boat, and if there is no friction between water and the boat, then the boat will move backward by 2 meters. Okay, the boat will move backward by 2 meters. I hope this calculation is clear to everyone. हमें करना क्या है? हमें बेसिकली जो इनिशियल पिक्चर है उसमें कहीं पे भी ओरिजिन चूज करके एक्स कोऑर्डिनेट ऑफ सेंटर ऑफ मास निकाल देना है, और कहीं पे रिमूव्ड, कहीं पे अलग हमें एक नई पिक्चर बनानी है जो भी चेंजेस हुए हैं सिस्टम में उसके साथ, और कोई डिस्टेंस वहां से वहां तक का अज्यूम कर लेना. जैसे मैंने ए अज्यूम किया तो आप एक्स या एक्स नॉट या कुछ भी अज्यूम कर सकते हैं, और फिर इस नए पिक्चर के लिए फिर से एक्स कोऑर्डिनेट ऑफ सेंटर ऑफ मास निकालना है और दोनों को इक्वेट कर देना है. दैट विल गिव यू द आंसर. वाई एक्सिस में क्या हो रहा है? हाँ जोए, वेरी गुड क्वेश्चन. जोए पूछ रहा है हाउ डू वी नो VCM x is 0. It should be actually written in the question. Very good. Yes, it should be written in the question. The boat and the man are stationary, and now the man moves to the other end of the boat. Okay? It should be written in the question. Because the boat moves because the x coordinate of center of mass must remain constant. Cannot the center of mass cannot move because there is no external force along that direction, right? That is why if you have tried skateboarding, it is initially very, very difficult because आप चढ़ो skateboard पे, अभी देखो क्या होता है. Unless of course you've had practice, your brain has had time to learn how to handle the situation that the ground beneath your feet is movable, right? So we have lived our lives with the absolute assurance that the ground beneath our feet is immovable. What if it was movable? Then what would happen? Then this would happen. Where can you experience it? You can go and climb a small boat. That will be one way, or you can simply take a skateboard, stand on the skateboard, and then try to walk on the skateboard, right? तो थोड़ा केयरफुल रहना पड़ेगा, मुंह के बल गिरना एक बहुत बड़ी पॉसिबिलिटी हो जाएगी फिर. The reason that you will fall is because as you move forward on the skateboard will simultaneously move backward, and uh, there is no mysterious reason. There is no mystery here. As you try to move forward on the skateboard, you apply a force on the skateboard in the backward direction. Now, when you are on the ground and you walk, you apply a force on the ground in the backward direction, but the ground does not move because the ground is a part of the earth. So, when you apply a force backward on the skateboard moves backward, and the skateboard applies a force on you in the forward direction, therefore, you move forward. So it is nothing mysterious. What has happened here is that when the man starts to move towards the other end of the boat, he is actually applying a force on the boat in the backward direction, and the boat is applying a force on the man in the forward direction. Therefore, the man is moving forward, and as a consequence, the boat moves backwards. But the fact is that this is an information which is, which has to be processed by your brain. If you are doing this practically, and if your brain is not used to this, then you will be disoriented, you will be disbalanced. So I find it very fascinating that आप skateboard पे so my kid will stand on the skateboard, and then their brains have processed how to handle. Therefore वो अपना चल रहे हैं और skateboard पीछे चल रहा है. But I will not be able to do it because of the fact that my brain will not be able to process this information. So, how many of you know how to skateboard? Anyone? Radhika knows, and Anaya knows. ईशुजोत को नहीं पता. ईशुजोत ट्राई किया कभी स्केटबोर्डिंग? रजत के लिए इजी है, लेकिन पहले तो नहीं इजी रहा होगा ना. आई मीन, यू रिमेम्बर द फर्स्ट टाइम रजत व्हेन यू. हाँ तो कभी कभी हाँ. So the reason is that your brain is trying to adjust to this new situation where you are walking forward and the ground beneath your feet is moving backward, right? I mean, this is extremely disorienting, but after a couple of days, of course, then you get used to it. Oh, what about the rocket? What about the rocket? Now, can you tell me what happens to the rocket? Anybody willing to take? तो रॉकेट में क्या होता है, रॉकेट में क्या होगा? जो मैंने रॉकेट का एग्जांपल दिया है, वो रॉकेट में क्या होगा? वेयर इज द सेंटर ऑफ मास? नहीं, बोट जैसा नहीं है. रॉकेट थोड़ा तैर रहा है स्पेस के पानी में. क्या बोल रहा है? प्रिंसिपल्स आर द सेम. हाँ, गैस पीछे जाएगा, रॉकेट आगे जाएगा. सेंटर ऑफ मास कहाँ रहेगा? चलो, I'll answer the question. Please take a screenshot of this. You will do it. मतलब अब ये बोलना बड़ा अजीब लगता है. You will do it at home. You are already at home. So do this as homework. We'll discuss this question in the next class. Please take a screenshot. I'll tell you what happens to the rocket. ले लिया screenshot सबने? Please take a screenshot of this. 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 Please take a screenshot. Then this. And then finally this. Okay, I'll tell you what happens to the rocket. So this is the rocket. This is, of course, our chosen system. What is the external force on the rocket? External force is 0. What is the velocity of center of mass of the rocket? 0. Right? Everybody is agreeing with this, right? So the x coordinate of center of mass of the rocket must be constant. That means that even though the rocket has traveled 1,000,000 miles, the center of mass will remain here. Center of mass is not going to go anywhere. So basically what is going to happen is that the gases which are left here and the trail of gases which is left by the rocket, if you calculate the center of mass of the rocket and the gases, you will find that the center of mass is here. Center of mass will not have moved. Okay, so is it like the boat and the man problem? Yes, in a sense it is. As the man moves, the boat also moves, right? It's very weird, yes. नहीं, बात तो वही है ना अबिन, फिर आपने फिर इसका जवाब कैसे दिया मेरे को? How did you answer this question then? Right? I mean, or you don't agree with the answer. एक ही ऑप्शन हो सकता है ना ये क्वेश्चन से, या तो आप ये आंसर से, या तो आप सहमत नहीं है। ये आंसर सही लिखा है मैंने कि गलत लिखा है? आंसर गलत लिखा है, सही लिखा है? बताओ बहन। Does this mean that V1, V2, V3 are all constants? तो किसने बोला? जोहेब ने बोला, सॉरी। बताओ जोहेब। जोहेब तो बोल के गायब क्यों हो गया? सो गया क्या? ये मैंने सही लिखा है या गलत? आर यू अग्रीइंग विद दिस और नॉट? ये नो होना चाहिए कि नहीं होना चाहिए? हाँ, तो इसका मतलब कि इसका मतलब कि वेलोसिटी ऑफ रॉकेट कुछ वैल्यू हो सकती है, वेलोसिटी ऑफ गैस कुछ वैल्यू होगी ना। अंडरस्टैंड व्हाट आई एम सेइंग? हाँ, वेरी वेरी वियर्ड, वेरी वेरी वियर्ड। सेंटर ऑफ मास रिमेन्स देयर ओनली, रॉकेट उधर चला जाएगा, गैसेस पीछे चली जाएंगी, सेंटर ऑफ मास वहीं का वहीं रहेगा। चलो ठीक है, so I'll see you guys in the next class. Please do that question, we'll discuss that question in the next class. What is the distance traveled by these two guys, by the boat, when these two guys they exchange places? ठीक है, प्लीज ट्राई दिस क्वेश्चन। नेक्स्ट क्लास में ऐसा नहीं होना चाहिए कि नहीं हमने नहीं किया सर, 5 ही मिनट लगेगा करने में, या तो सही होगा या गलत होगा, खत्म कहानी। यू कैन कंपेयर। चल, आई विल नाउ। दिखाया तो था, ऋषिक क्या कर रहा था, सो रहा था क्या? सोने का टाइम नहीं है अभी। पहला जल्दी जल्दी उसको स्क्रीनशॉट मारना। अच्छा, स्क्रीनशॉट ले जल्दी जल्दी से। क्या बोल रहा है? इफ द रॉकेट इज इन स्पेस, सेंटर ऑफ मास। हाँ, इफ द रॉकेट इज इन स्पेस देन, क्योंकि अगर रॉकेट अर्थ वाला है ना, तब उसके ऊपर ग्रेविटी की फोर्स लगी हुई है ना, राइट? दैट इज आल्सो एक्सट्रीमली वियर्ड। सेंटर ऑफ मास ऑफ द रॉकेट एक्सेलरेट्स वेयर, अर्थ वाला जो इलॉन मस्क लॉन्च करता है, उसका जो सेंटर ऑफ मास होता है वो किधर जाता है रॉकेट का? एनीबडी? एनीबडी? है ही नहीं, क्या बोल रहा है? रॉकेट का सेंटर ऑफ मास तो होएगा ना, सेंटर ऑफ मास तो हर ऑब्जेक्ट का होएगा। जो स्पेस एक्स का रॉकेट रहता है उसका सेंटर ऑफ मास कहाँ ट्रैवल करता है? हाँ, वेरी गुड, यस, इनिशियली ऊपर जाता है, क्योंकि जब आपने देखा है ना, जब काउंटडाउन खत्म होता है तो द गैसेस दे कम आउट एंड दे हिट द ग्राउंड, huge amount of gas comes out and hits the ground. Basically, the ground is applying a force now on the system, which is the rocket plus the gas, and therefore it pushes the center of mass upwards. But once the rocket has lifted off, right? Once the rocket has lifted off in such a way that the uh, outgoing gases they are not hitting the ground anymore, then the rocket and the gas system is only under the influence of gravity, and thereafter the center of mass simply keeps on moving down, right? And therefore you require all that fuel to push the rocket into space. That is the reason why you need the fuel to push it into space. चल, मैं जा रहा हूँ अब। I'll see you in the next class. Okay? आज थोड़ा लेट हो गया था, again I'm sorry for that. चल, bye bye.